Hello class, we're up to lesson 26, mixing compounds with water to make solutions. So we were talking, and so far in our discussion, our chemical reactions have been in the dry form, such as powder or crystal, but oftentimes we work with, and we have in lab, as you know, with solutions, which is an aqueous solution or something, a compound that's mixed with water or something else. When we use these type of solutions, because water is involved, the measurement is called molarity instead of moles, and I'm on page S247. And the two new terms that we need to know is the compound that we're mixing with the water or the liquid is called the solute, the solid part, the solute. And whatever liquid we're mixing it with to make the solution is called the solvent. So if we were making lemonade and we wanted to add sugar to our lemonade to make it sweet, the sugar would be the solute and the lemonade would be the solvent. So molarity, the definition of molarity is it tells how many moles of the solute have been mixed into 1 liter of solvent, okay, into 1 liter. So you can put 1 mole into a liter and it's a 1 molar solution, 2 moles into a liter and it's a 2 molar solution, 12 moles into a liter, and it is a 12 molar solution. So as you can see, since we do not increase the amount of liquid, we only increase the amount of solute, the greater the molarity of the solution, the more concentrated the solution will be. And we're going to do a demonstration of that on Monday. So what's our math? Well, if we want to create these molar solutions, knowing that we have 2 moles of something is interesting, but if we're in the lab, you know we need to convert it to grams. And it's the same type of math that we've been doing for the last several chapters. So I'm on the bottom of S248, and their example here is how many grams of potassium hydroxide powder do you need to make a 5 molar solution of potassium hydroxide. So you take your potassium hydroxide, you break it up, you find the atomic mass of each element, you multiply it by how much of the element it is and add it together, and we get our formula weight. That's not news to us. When we go up on the top of S249, it asks us to work out our own. It is what solution is it? A 5 molar solution. No, it's not. It's a 2 liters of a 3 molar calcium chloride solution. So you've got your calcium chloride. You have to add your subscript 2 here to balance that out. You find your formula weight by taking your calcium and your chloride, multiplying it by your atomic weight and adding it together. So your formula weight is 110 grams. Now that's for 1 mole. It says we need 3 moles, so it's 3 times 110 grams, but they want 2 liters. So then you have to take your 330 and multiply it by 2 to get your 660 grams of calcium chloride. We just need to be careful with all the steps they do in here. Their second example here is a barium oxide. You take your barium, you take your oxide, you find your formula weight. Here it is. Then they kind of walk you through it here. In your 1 solution, your 1 molar solution, there's your formula weight in grams. They want a 12 molar solution, you multiply that by 12. And they want 5 liters of it. So you multiply that by 5 to get your grams. So these are actually going to be more simple than what we've been doing. So good luck and have fun with these, and we'll see you in class on Monday.